Okay, now in this class today we are going to start with the new topic area under the curve. Now if you see a function, any function that is represented as y equals to f of x, and you call the area under this function, the region under this function just below the any value of x as a of x. Okay, if you define the area of this function to the left of x as a upon 8 a of x, area function, then would you agree that as you're going to increase the value of x, the area is also going to be increasing?
Yeah.
So now you can consider a small increase in x. So previously this was the area under the graph. Now since you have increased x slightly, so the new value of x is going to be x plus delta x. Del x would imply, just implies that you have a very small change in the value, a very
Okay.
small. So because of this very small change in value, it results in a very small change in the area as well. Now, when your function, when you insert x, the new value of the x as x plus del x, the area bounded by the curve and the x-axis is now going to be a of x plus delta x. So
Okay.
the total area has increased. So if you want to figure out this delta A, the delta A meaning the small change in the area, what you could understand is you find the area at this value and minus the area at the value of x.
Okay.
So if you do that, you end up getting delta A.
Okay.
That's what's done. Delta A is area to the left of x plus del x minus the area to the left of x.
Okay.
So that is delta A for us. Now, if you see this shape, it looks like this. Okay, it looks like this. But since it's very small, it can be approximately called a rectangle. If you approximate this shape to a rectangle, then what is the area of the rectangle equal to? Length times width.
Yeah.
So the length of the bar denotes the value of the function. If I am calling it to be a rectangle, approximating it to be a rectangle will have a fixed length, and that is going to be equal to y. And this is delta del x. And we know that the area was equal to delta A. So delta A in this case is going to be equal to y times delta x, or you can say y is going to be equal to delta A upon delta x,
Oh,
approximately equal to.
yeah.
Now, if this width of the rectangle becomes very small, then for small change, do you remember we studied this that for small change delta y upon y was rough delta y upon del x was roughly equal to dy by dx
Yeah.
for small change.
Yeah.
Now, if you have delta a upon delta x, it is going to be roughly equal to approximately equal to dA upon dx. So when delta x approaches 0, meaning it becomes very small, then your delta A over delta x becomes dA over dA by dx. And you know that delta A upon delta x was approximately equal to y, so dA upon dx is also going to be equal to y.
Okay.
So if dA upon dx is equal to y, then dA is going to be equal to y times dx, and if you integrate this, what do you get? Integration of dA is going to be a area is going to be integral of y dx. Now this means that what was y initially? Y was the equation of the function. So this tells you that if ever you want to find the area, if you integrate the function with respect to x, you're going to get the area bounded by the curve and the x-axis. And if you integrate the function having limits as a and b, it is just going to give you the area confined between the two limits. So hence, from this you can understand that integrating a function is going to give us the area under the curve. Do you
Okay.
get this point?
Yeah, I get it.
So integrating a function with some limits is going to give you the area under the curve between those limits. Okay, and
Okay.
this is valid for f of x greater than equal to 0. We are looking at the in area above the x-axis right now.
Okay.
Okay, so far is it clear?
Yeah, sure.
Okay, let's look at an example. Find the area of the shaded region. So I know this in knowledge that integrating a function is going to get me the area bounded by the curve and the x-axis. And if I apply the limits from 0 to 3, it is going to give me the area bounded between these two limits. So to find this area, all I need to do is integrate the function with respect to x and apply the limits from 2 to 3, isn't it?
Yeah.
So to find the area, I'm going to integrate this further, x cube upon 3, and then apply the limits as 3 2. When you apply the limits as 3 2, when you apply the upper limit, you are going to get 3 cube upon 3 minus 2 cube upon 3, 27 upon 3 minus 8 upon 3, which is going to come out as 19 upon 3.
Okay.
19 upon 3 units square. That is the area for us.
Okay.
Make sense?
Yeah.
Okay. Let's look at another example. Now we have a different function and we need to find the area bounded by the curve and the x-axis from the limits 1 to 3. Now I know that to find the area, all I need to do is integrate my function with respect to x and apply the limits 1 to 3. Now it's a different function, so it needs to be integrated in a different way. We know that integration of 1 is x. What is the integration of e to the power of half x?
E divided by half to the power 1 upon 2x.
E to the power of half x divided by half, isn't it?
Yeah.
And then we're going to apply the limits 3 1. So if I simplify this, you are going to get x plus 2 e to the power of half x. The limits are 3 to 1. Apply the limits first. When you apply 3, you're going to get 3 plus 2 e to the power of 3 upon 2. Minus when you apply 1, you get 1 plus 2 e to the power of 1 upon 2. So 3 minus 1 is going to be 2 plus 2 e to the power of 3 upon 2 minus 2 e to the power of 1 upon 2. This should be your final answer.
Okay.
No questions so far?
No, sir, understood.
Okay, let's try this one now. Now, what do you observe over here? You observe that the area, the shaded area is below the x-axis.
Yeah.
Okay, so I'm going to show you the working that if I integrate the function x square minus 3x from 0 to 3, technically I'm going to get a negative answer.
Okay.
So x cube upon 3 minus 3x square upon 2, apply the limits 3, so you get 27 upon 3 minus 27 upon 2, and when you apply the limit 0, you get 0. Is 27 upon 3 a larger value or 27 upon 2 a larger value?
27 upon 2.
27 upon 2 is a larger value.
Yeah.
Okay, so can you solve this and give me the answer?
Yeah. Minus 9 upon 2.
Minus 9 upon 2. Now, we know that area can never be negative. So this negative sign just indicates that area is below the x-axis. As a final answer for the area, you are just going to write 9 upon 2 units square. If you want, you can like draw the diagram and copy down the solution.
Yeah.
If you are done, are you done?
Almost. I'm just on the last
Okay,
part.
if you're done, you can try the next part as well, next question
Okay.
as well. But before all the technique that you need to use in the next question is that you are first going to find the area between 0 and pi because that lies above the x-axis,
Yeah.
and then you are going to have a separate integration for the function from pi to 3 pi by 2,
Okay.
and then at the end you are going to add the two answers.
Okay.
All right, so what we are going to do in this question is that we are going to integrate this part of the function separately. I'm going to call it a1, and the area that is below the axis as a2, because I'm going to integrate this function from here to here again, having different limits.
Okay.
So the shaded area comprises of a1 plus a2. A1 can be found by integration of 2 sine x from 0 to pi, and area 2 can be found by integration of 2 sine x from pi to 3 pi by 2. Now please keep this thing in mind that this answer is going to be negative. So what we are going to do is we are going to turn that value into a positive value because we know that area cannot be negative.
Okay.
Okay, so integration of 2 sine x is simply 2 minus 2 cos x, right?
Yeah.
And you apply the limits from pi to 0, minus 2 cos x. You apply the limits from 3 pi by 2 to pi. Okay, minus 2 cos pi. Cos of pi is minus 1. That's going to give you 2.
Okay.
Minus, when you plug in 0, cos of 0 is 1. 1 times minus 2 is minus 2. So you get the answer as 4 from here. Plus, when you apply the limits 3 pi by 2, so minus 2 cos 3 pi over 2 is 0, minus minus 2 cos pi is 2. So you see the answer from here is coming out to be negative 2, but I'm only going to take it positive 2 because area, the negative sign just implies that the area is below the x-axis. If I want to find the total area is going to be the sum of both the areas. So 4 plus 2, that is 6 units square.
Okay.
Any other thing that you want to ask?
No, sir. Understood.
Okay. Okay, the next thing that we are going to discuss is area bounded by the curve and the line, or area bounded by the two curves. So if two functions are there, f of x and g of x, and they intersect, so they share a common intersection points, Let's say the x coordinate of this point is a and the x coordinate of this point is b. So to find the area enclosed by between the two curves, what you can simply do is you take the you find the integral of the upper curve, that is integration of f of x from a to b, minus the integral of the lower curve, that is also going to have the same limits a and b. If
Okay.
you do this, you're going to get the area enclosed between the two curves. Do you
Okay.
understand this?
Yes.
Sure.
Yeah.
Okay. So I also write this as area between the two curves is going to be integration of upper curve minus integration of lower curve, and the limits are going to be same because they both are intersecting.
Okay.
Okay. So let's try this example. The curve y equals to 2 root x intersects the line y equals to x at the point 4 comma 4. So in this question, the intersection points is already being given 4 comma 4. You need to find the area of the shaded region bounded by the curve and the line. Okay, so area bounded by the curve and the line. You can do it in two ways. The first way is going to be you consider this to be the upper curve and this to be the lower curve or the lower line. Because the intersection points are same, so the integration is going to be done from 0 to 4. Area, or you can say the shaded area, that is the area bounded by the curve and the line, is going to be found out by integrating the upper curve with respect to dx from 0 to 4 minus integration of the lower curve from 0 to 4. The upper curve is this, that has the equation 2 root x. The lower curve is technically a line in this case. So now I'm going to integrate this. So integration of 2 root x is going to be 2x to the power of 3 upon 2 divided by 3 upon 2. Okay, since the limits are same, I can apply the limits at the end as well.
Okay.
Minus what is the integration of x? X
Uh,
square upon 2, right?
yeah.
Okay, so if you simplify this, you get 4 upon 3 x to the power of 3 upon 2 minus x square upon 2, and the limits are 4, 0. Okay, please plug in the limits.
Uh, it's coming to 8.3.
8 upon 3. Very good. So 8 upon 3 units square.
Okay.
Now, I could also show you an alternate method to find the area. As an alternate method, what you can do is you can first integrate the curve, the upper curve, from 0 to 4. So integration of 2 root x from 0 to 4, that is going to be 2x to the power of 3 upon 2 divided by 3 upon 2. which is same as saying 4x upon 3, 4x to the power of 3 upon 2 upon 3 to the power of, limits are 4 and 0. So if I plug in the limits, 4 to the power of 3 upon 2 times 4 divided by 3, I'm going to get 32 upon 3 unit square. This now, when I am going to integrate this curve, I'm going to get the area bounded by the curve and the x-axis, all of this area. Okay. When I go for the alternate method and I apply integration on this curve from 0 to 4, it is going to get me the area to the left of 4 and above the x-axis, so this entire area. But I don't want the entire area, I just want this area.
Yeah.
So in order to find this area, I'll have to subtract this triangular area from the working.
Okay.
So area of triangle is going to be half times base, which is 4, times the height, which is also 4, that is 8 unit square.
Okay.
So shaded area, the required area is going to be 32 upon 3 minus 8, which is
Coming to 8 upon 3.
exactly 8 upon 3. Okay,
Okay.
both of the methods are right. Okay, let's try this one now. Do you need time to copy the previous question?
Yeah, sir. Just a second. I've copied it, sir.
All right, please try this one. All right, so this question says that the curve y equals to x square minus 4 intersects the x-axis at the points A and B, and the line intersects and the curve intersects the line y equals to x minus 2 at the points C and B. You need to find the coordinates A, B, and C. To find the coordinates of A and B, I can just use my equation of the curve and set it equal to 0. So from here you can work out, you're going to get plus minus 2. Obviously A is minus 2 comma 0 and B is 2 comma 0. To find the coordinates of C, I'm going to solve the two equations simultaneously for the equation of the line and the equation of the curve. So x square minus x minus 2 equals to 0. If I do that, you are going to get x2 values, two values of x. One is going to be plus 2 because it has a coordinate of b as plus 2, and the other is coming out to be minus 1. So obviously C is going to be minus 1 comma something. Let's check out the y value when x is minus 1. So when x is minus 1, y will be equal to x minus 2, that is minus 1 minus 2, hence minus 3. Therefore,
Yeah.
C coordinates are minus 1 comma minus 3. Now for the second part, we were asked to find the area of the shaded region. So shaded area, for shaded area we can follow this upper curve, integration of upper curve minus integration of lower curve. If the upper curve in this case is the line, and it needs to be integrated from from minus 1 to 2, right?
So won't it be, yeah, 2 and minus 1.
2 and minus 1. Okay,
Yeah.
right. So integration of x minus 2 is x squared upon 2 minus 2x, limits is going to be 2 minus 1, minus x cube upon 3 minus 4x, limits is going to be 2 and minus 1. When you apply the upper limit 2, you get 4 upon 2 minus 4 minus 1 upon 2 plus 2. When you apply the upper limit 2 over here, you get 8 upon 3 minus 8 minus 1 upon 3 plus 4. Let's solve this now. 2 minus 4 is negative 2. Negative 2 and negative 5 upon 2 is minus 9 upon 2. Okay. Minus 8 upon 3 minus 8 minus 4 minus 1 upon 3 is coming out to be minus 9. So minus 9 upon 2 plus 9. Alright, so now you should have asked me that, sir, why aren't we taking it to be positive 9 upon 2? Well, that is because both of the areas are below the x-axis.
Yeah.
So we are just gonna go take this minus 9 upon 2 and minus 9 upon 2 plus 9. We are not going to change the sign over here. Is
Okay.
4.5.
Okay.
If this method seems to be confusing, what we can just do is we can do this as well. Okay. Let's try to integrate x square minus 4 from minus 1 to 2. If we just do that, what value would we be getting? Minus 9 upon 2.
Yeah.
So the answer to this is going to be minus 9 upon 2. Okay, but if I say, okay, the area cannot be negative, so I can take 9 upon 2.
Okay.
As far as the triangle is concerned, area of the triangle is going to be half times base. The base can be from minus 1 to 2. So that is 3 units. And this height of the triangle was minus 3, so again it's 3 units. So 9 over 2.
Okay.
Is the area of the triangle coming out to be same, right?
Um, I think.
Please confirm this answer. X square minus 4 integration. Is it coming out to be minus 9 upon 2?
I'll just check.
No, this area was 9 actually. My bad. This area should have been 9. If you do the
Okay.
calculation, this area is going to be 9. So we have the area bounded by the curve and the x-axis to be 9, and area bounded by the line and the x-axis to be 9 upon 2. So this shaded area is going to be 9 minus 9 upon 2, that is 9 upon 2, which is 4.5 unit square.
Okay. Okay.
Make
Uh,
sense?
yeah. Sir, could you go back to the previous slide for 1 second?
Yeah.
Sir, I wanted to ask in the step where it's x squared upon 2 minus 2x, it's fine if you take it under like x squared minus 4x upon 2 before
Where, where,
solving.
where do we have x squared minus 2 upon x? This one?
Yeah, the third step, it's fine if we take it under a single denominator before solving, right?
Yeah, yeah.
Okay. I just wanted to ask that.
All right, done. Should I move on?
Yeah, sir, you can move on.
Try this one.
Okay.
So 1 plus cos x equals to 1, cos x equals to 0, x comes out to be pi by 2. Okay, so since the graph is symmetrical, this is going to be minus pi by 2. So shaded area is going to be the integral of the upper curve, that is 1 plus cos x from minus pi by 2 to pi by 2, minus the integration of the lower curve, that is 1 from minus pi by 2 to pi by 2. So x plus cos x integration is
Sin x.
sin x. Okay, now also what we can do is we can simplify this. We know that the limits are same and both curves are lying above the x-axis, so and have the same limits. So I can write this as 1 plus cos x minus 1 from
Okay.
minus pi by 2 to pi by 2 dx. So I can see 1 and minus 1 simplified out. Cos x, integration of cos x from minus pi by 2 to pi by 2 dx. Cos x integration is sin x.
Yeah.
Limits is pi by 2 to minus pi by 2. So sine of pi by 2 minus sine of minus pi by 2. Sine of pi by 2 is 1 minus sine of minus pi by 2 is minus 1. So the answer comes out to be 2 units square. Okay. Is that clear?
Yeah, sir, it's clear.
Okay. Now I need to find this shaded area. To find this shaded area, what I can do is I can integrate the curve from 0 to 2. So it's going to give me the area bounded by the curve. Okay. And
Okay.
then I can take out the area of this rectangle
Um,
and then get the shaded area. This is one thing, one way. The other way was simply consider this to be an upper curve and consider this line to be the lower curve, which is y equals to 2. So I'm going to take the first approach now. I'm going to find the area bounded by the curve and the x-axis. That means I'm going to integrate 2 plus 3x minus x square from 0 to 2. So I'm going to get 2x plus 3x square upon 2 minus x cube upon 3. And you apply the limits 2 and 0, right? So when you apply the limits 2, you get 4 plus 6 minus 8 upon 3. Minus when you apply the limit 0, you are going to get 0. If you solve this, I'm getting 22 upon 3 units squared. That is the area bounded by the curve and the x-axis. Now what is the area of this rectangle? The area of this rectangle is 2 times 2, that is 4. So the shaded area is simply going to be 22 upon 3 minus 4, which comes out to be 10 upon 3 units squared. Understood? This could also be done. I hope I'm not going too fast. Is it clear? Sorry, your mic is mute. Can you hear me?